Hi, this is Dr. Liu. In this video, we'll discuss how to solve quadratic equations. So a quadratic equation is an equation that has a quadratic term, at least one quadratic term, if not a linear and also a constant term. So things like this, let's say 3x squared plus 2x minus 5 equals 0. This is quadratic equation. And this is the quadratic term. And this is a linear term, and this is constant. So as a quadratic equation, we have a square of the unknown variable x, and as a result, we have two roots. So two roots. And there are various situations what the two roots could be. They could be two different roots, and they could be identical roots, but they're both real. And they could also be, well, you cannot really find any roots. You may have encountered those situations. We call them, these roots are complex roots. So we don't really discuss this because we don't really need complex numbers, but most of the times we see this. We see different roots coming out, and very occasionally we see some identical roots coming out. So let's theorize the quadratic equation into these terms: ax squared plus bx plus c equals 0. And the solution, let's capitalize that, to this equation, we're assuming that a is a quadratic factor, and b is a linear, and c is a constant, not the other way around, like c is quadratic. No, a is a quadratic. So the solution is x has two roots, so 1 over 2a minus b. The two roots come from here, plus or minus. You take one pass, you take the plus, you get one value, and then you take the minus, you get a second value. And here's b squared minus 4a times c in the square root. Oops. Let's use a ruler. And these all in parentheses. So we have one of the values 1 over 2a minus b plus the square root. The other value is 1 over 2a minus b minus the square root. And we call the b squared minus 4ac the discriminant. Or the delta is equal to b squared minus 4ac. So to correspond to these two roots, what kind of two root situation? We have delta equals, okay, let's say delta is well, greater than 0. Then we have the two different real roots. Delta equals 0. Apparently this whole thing drops out, so we only have one value, minus b over 2a. So they're identical roots. And when delta is less than 0, we have negative inside the square root without complex numbers. We'll just call them, there's no real roots or no roots. Right, so these are corresponding to these situations. Let me say this is say 1, 2, 3 possibilities. 1, 2, and 3. Okay, so let's do an example. We have a free fall problem, and in the free fall problem we encountered this quadratic equation: minus 4.9 x squared plus 3.5 x plus 1.2 equals 0. Alright, so a is negative 4.9, B is 3.5, C is 1.2. Alright, so we can use this formula. So x is equal to 1 over twice the negative 4.9, so negative twice 4.9 minus b. B is positive, so minus 3.5 plus minus 3.5 squared minus 4 times a. Remember, a is a negative, negative 4.9, and c is a positive 1.2 under square root. Let me bring out a ruler, make it easy. Alright, so we have the denominator minus 9.8. This some of you may recognize as gravity, 9.8. That's exactly where that number came from. Minus 3.5 plus minus, so 3.5 squared, and negative negative, so plus 4 times 4.9 times 1.2 under the square root. Okay, just from taking a look inside, this is the discriminant, and the discriminant is positive, right? A square plus a positive quantity, right? So we're in this scenario where we have two different real roots, right? We'll be able to calculate them with a calculator. So let me bring my calculator up, and it's Python again. So what I did was I defined a function which carries out this whole calculation. Actually, this whole calculation, if I just apply the value of a, b, and c, it'll just calculate this whole thing with a plus sign, and then this whole thing with a minus sign. So it's much easier than having to type this into a calculator. It's more or less that's like a calculator with this formula embedded. So I got the numbers, two separate roots, minus 0.25 and positive 0.97, because all my numbers are 2 decimal places, so I want to keep 2 decimal places. So minus 0.25 and plus 0.97. Okay, so minus 0.25 plus 0.97. And because this was a free-fall problem where this x was actually the time t, so the units were in seconds. So this is basically what this means is you're tossing an object upward with 3.5 meters per second speed at a height of 1.2 meters, and then because of gravity, it will take some time before the object falls onto the ground. So this is the time it takes. Apparently, with physics applied to this problem, this is not a valid solution, although both are valid roots for the quadratic. Right? Once we know the physics of this problem, we'll decide that this is the time after time 0. This is when the object, say a ball tossed upward, will land on the ground after it was tossed. Right? So without physics, these two roots are both valid roots for quadratic. Okay, so now we have a few more minutes. I want to review two typical mistakes that you may make when you're solving a quadratic. So mistakes. So number one mistake, I see this very often, is cx squared plus bx plus a equals 0. So you might actually even memorize this formula, but you don't know what a is, what c is. You think that a is the linear term, and sorry, a is the constant term, and c is the quadratic, but it's not the case. A is the quadratic. So if you do this way, you apparently may get two answers, but they're just not relevant. So this should be, well, that looks like an X. So this should be incorrect. That's incorrect. And this is actually A. This is C. Alright. So that's one mistake. Another mistake is trying to solve a quadratic equation without actually using the formula. So this is number 2. So let's say we still have this formula, this quadratic equation right here. So minus 4.9x squared plus 3.5x plus 1.2. And someone will say, well, yeah, let's divide every term by x, and so that we will no longer have the quadratic. So that's equivalent to multiply everything with a 1 over x, right? So we have a minus 4.9x plus 3.5 plus 1.2 equals 0, so that 4.9 minus 4.9x is equal to minus 3.5 minus 1.2, and that's minus 4.7, so x is 4.7 over 4.9, so it's about equal to 1. So what's wrong with this then? Well, the apparent mistake is if you're multiplying an equation by this factor, every single term gets multiplied by this factor. So that goes to this. That's correct. And again, multiplied. That goes over here. That's correct. And then if they forgot to multiply the third term, they saw, oh, that's a constant term, so that's already easy to handle. But they forgot that they have to multiply this, so there's actually a missing. So missing 1 over x right here. So now you have 1.2 times 1 over x. You cannot combine with 3.5 anymore. 3.5 has no 1 over x. So this way it never really solves the problem. Just because you divide them, it doesn't really change the nature that this thing is a quadratic equation and it requires a quadratic formula to solve it. So the first thing to do once you see an equation is to recognize what type of equation it is. Is it a linear equation you can solve, or is it quadratic? If it's a quadratic and it is full-fledged with all three terms, quadratic, linear, and constant, you have to use this formula. Thank you.